Hi friends, from the Key of Education Zone channel, we are welcoming you to this video. This video is another important topic related to computer science hardware. It is regarding 8086 microprocessor, Intel 8086 microprocessor. Now before starting that, I have to tell you what is Intel 8086 microprocessor. It is a 16-bit register and it is better than 8085. 8085 related little bit you can able to get from our playlist. There you have this all videos regarding 8085. Now today we will start the discussion over 8086. Now before starting, I have to tell you, throughout the lecture we have several things to say, so don't skip it. Just go through it and you can able to get all the information regarding 8086. It is the introductory part. Here we will discuss the architecture, the features and etc. What's that you can able to get from there. Next video will be regarding more and more detail. Now let's start the discussion. Don't waste the time. 8086. 8086 means what? A 16-bit register. Already I told you. What is microprocessor? All the microprocessor, they have the thing fetch, decode and execute. Fetch, decode and execute. Here also it will fetch, decode and execute, but it is more than 8085. How? They can take instruction one by one. It will take at a time up to 6 instruction. They can make it queued and one by one it will be decoded and executed. So it will be better. It is 16-bit, moreover 8-bit, so that is also benefit. It has more address bus. This all we will discuss. See this. The features is coming on the screen. It is a 16-bit microprocessor. 8086 has 20 address buses. There was 16 address buses in 8085. Here we have 20 address buses. So it can locate or access up to 220 memory addresses or memory location. It can support 64K input-output port. It provides 14 16-bit register. 14 16-bit register. I repeat once again, 14 16-bit register. Getting the difference, I think you. Next, it has multiplexed address and the data buses, which they are AD0 to 15, that means total 16, and as well as A16 to 19, that means there are also 4. I told you that it has 20 address buses. Got it? It requires single phase clock with 33% duty cycle to provide internal timing. It has designed to operate 2 modes. It has 2 modes, minimum modes and maximum modes. Okay, and it can, that means this microprocessor can up to 6 instruction they can take from the fetch from the memory and queue it at a time. One by one it will execute, so it will make very faster. And the power supply is always same, just positive 5 volt, and the 40 pins dual inline package is in the our 8086. So before that, I have to tell you one thing more. These are the features. What you have to remember from here: 16-bit microprocessor, 20 address buses, they can fetch up to 220 memory location, 64K you have the input output memory, the address buses, that is 0 to 15, A16 to 19, this location, this addresses, this pins. Then they can operate in two modes, minimum and maximum, as well as at a time it can fetch 6 instructions. So one by one it will execute. In case of 8085, it was fetch one instruction, decode it, execute it, next one, fetch it, decode it, execute it. But here notice that they will fetch at a time 6, make them cute, one by one decode and execute, decode and execute. So it will be very faster. And obviously they have 40 dual pin line package. These all you have to remember. So this features, I think it is clear to you what you have to read. If you want to write down, pause the video, write down these features. Because it is a tutorial lecture, so what I told you, go through it, write down this, it will be better. Now see the 8086 architecture. In case of this architecture, we have to know two things. 8086 has two parts, BIU and EU. BIU means bus interface unit. Bus interface unit. It doing fetch the instruction, read the instruction, write data, and computes 20-bit address. This is the job of BIU. Whereas EU means execution unit. Execution unit, decode, set and execute. Just decode and execute. And all the instruction they will do by using ALU, 16-bit ALU. In case of BIU, we have several registers whose they are IP, CS, DS, SS, ES. Full form of that, IP means instruction pointer, CS, code segment register, DS, data segment register, SS, stack segment register, ES, extra segment register. BIU fetches instruction using CS and IP, and CS, written CS, IP, this all. Now see this diagram, it will make you very clear. What's this diagram? It is the internal architectural diagram of 8086. Internal architectural diagram. See here, all the registers details is given. ALU is there. So how the work will be goes through, it will be pictorial view, you can able to see from here. See here, just where the instruction is coming, I am telling in my mouth, so you have to follow the screen, else you cannot able to get it. And I am trying my level to best to make you sure that you can able to get this. See, here we have several registers. Now one thing we have to know that Intel 8086 is a 16-bit microprocessor. It has 16-bit data bus and 20-bit address bus. Just view it, the upper part where the memory interface, from this memory interface, the bus interface unit BIU is there. The upper part is BIU. This BIU taking the 16 signed address along with address and data bus, and 4 more address bus. See here, you can able to see just from this picture, this just below this memory interface, ES, CS, SS, DS and IP are there. That means they are the BIU part. Now here for the offset address is coming to here, through this BIU, that is the control bus from this, where from it is coming, that is 1 2 3 4 6 bytes instructions, they are queued here. Now the instruction decoder and control is there also. Just come to the lower part where the ALU operand and flags are there, and it will goes to the EU, that means where accumulator AL, lower and higher, two parts is there, 8-bit division, total 16-bit, B, HBL, CHCL, DHDL, and SP, BP, SI, DI, all are there. Here one thing you have to remember, this basic architecture is this. This picture is the basic internal architecture, where BIU means what I already told you, and EU was their activity, it is already discussed. So this is the basic architectural model. See, upper layer, upper part is the BIU and the lower part is EU. I am divided by dotted line also to make it separate, where which one is work type of work is done. That is already I told you. For fetch, decode, this type of operation, fetch type of fetching and decode, this is BIU part, and EU only decode and execution part. This is given. See here, this A part, A means accumulator. The mnemonics I am telling here also. EU part contains AX, that is accumulator, B base register, C count register, D data register, SP stack pointer, next BP base pointer. These two are very basic. Default stack segment is known. Then SI source index register, DI destination register. This all you can able to get. Already the pictorial view you can able to see. You can reverse back, you can check it once more also if you want. There are referred as the general purpose register, although as seen in the names by their name you can able to get from here. Now AX, BX and CX and DX register can consider two 8-bit register, a high bytes and low bytes. This allow bytes operation compatibility with the previous generation of 8-bit processor, and 8080 and 8085 source could be translated into the 8086 code and assembled as 8-bit register. So what is that? Everywhere 8080 or 8085, they are all you can able to get 8-bit register. Now in case of 16-bit register 8086, that registers will be 8 byte, but that will be divided in two parts. That is why it is called 16 bits. If I have two parts, that high and low, then it will be utilized as a 8 as well as 16. This benefits you can able to get. Now in this architecture, one thing more I have to tell you, that here two things you have to remember. One is BIU part. BIU part means bus interface unit, generates 20-bit physical memory address and provides the interface and external memory, ROM and RAM. And as mentioned, I told you that earlier 8086 has single memory interface. In case of architecture, if you are studying this thing, you have to knowledge, you have to remember that 8086 has a single memory interface. To speed up the execution, 6 bytes instruction, 6 bytes instructions are fetched in advance and keep it 6 instruction in queue, while 1 by 1 instruction will be executed in the execution unit. And hence after this execution of the instruction, the next instruction directly fetched from the instruction queue without having to wait for external memory to send the instruction. And that's why it is called pipelining, and it is helpful to speed up the overall execution process. Okay? And another thing, that 8086 BIU produces 16 physical memory address. See here, from the screen also you can check. Here EU is also contain the flag register, which will collection of the condition bits and control bits. The condition bits are set of cleared by execution of an instruction. And we already told you this condition bits and control bits. This control bits instruction controlled by the same operation of the CU. Suppose in case of CPU, what you are doing, bit 0, then CF flag sent to carry out the MSB. Bit 2, that is PF, parity flag, send the result has even parity. Bit 4, AF, auxiliary for BCD arithmetic. 6, bit 6 and bit 7, bit 6 gives you the 0 flag and bit 7 gives you the sign flag to set result to 0, MSB to the result. Bit 8, the TF gives you the single step flag trap. By the name you can able to get this, also I am not explaining. After all, I will explain all the things. The bit 9 IF, that is the interrupt enable flag, and bit 10 DF, the string instruction direction flag, as well as bit 11 gives you the overflow flag. So here you have to remember this bit 1, 3, 5, 12 to 15 are undefined, and 0 to 7 are the compatible of 8085. One thing you have to remember, what I already told you, that there are several flags. I already told you that B0 to B11, this all. Now these bits, what purposes they are using, that is given here. Now this all the instructions, what way it will work, these all is given the discussion. These are the part of EU, that means they all were related to our execution purpose. And here what you have to remember, these all directions is also given to you. This extra segments or the stack segment or the code segment, when from the BIU it is coming and when it will becomes to the EU part, how they will execute. In this pictorial view, the programmer's model you can able to see. See, upper part, these are the BIU part, where we have ES, CS. The full form is known to you. Till if you forget, just beside right side you can able to check it. Now what's their activity, we have to know. This all are there, ES, CS, SS, DS and IP. So this is the BIU part. BIU full form, I think it is right now clear, that is bus interface unit. Their purpose of fetching, mainly fetching operation, data read, write, etc. So main part will be solved. It is 20 bits adder part. So it will add. Next come to the EU part. EU, we have accumulator, base register, count register, data register. That means A, B, C, D. They have 4 division, 2 division. That means H, higher part and lower part. Okay. Now when I segment this, what it will becomes? The segment of address segment register value shifted to the 4 phases to the left: code, stack, data, extra. Code, stack, data, extra. Remember it. Now when it will come, then here from the data will comes to 64K data segment. Code will comes as 64K code segment. In this way the segments are from 0 to 64K. In features we already discussed, and can overlap, start an address that ends with 0H. So this is the segments part. Now the memory terminology, we have several memory terminology we have to remember: CS, ES, SS, DS. What's their purpose? Just follow this. The memory segment will be 0 to 10 FFFFH. Already you know, in case of microprocessor it will be in hex format. So in hexadecimal formats way, how it will be segmented, this terminology you can able to get from the screen. Once more you have to remember, segments are up to 64K and can overlap. So maximum 64K, 0 to 64K it is possible, and it can overlap. So 64K means if I it is transferred to the hex code, then it will be 0 F F F F F H. So this is the highest address. Got it? The segments are given in the screen. You can able to see from there, and I am telling up to 64K you will able to get. So when I convert the 64K to the hex code, then what will generate? That will be the highest address. Okay. So till now what we read? The features of 8086. Next, the internal architecture. This internal architecture, we have several segments. Right now we are discussing this segments. So up to this level I think it is clear. If not, then gives us command, interact with you. Without interaction no study will complete. This all are tutorial lectures. So if you cannot able to learn it, then it will be totally blank. Got it? Up to this level is it clear? Now the next part we have to discuss what? That we will discuss right now. The thing is that the stack segment, in your picture you can able to see here the SS SP, they are giving the instructions. It is coming to the memory segments. Now in memory 0H to 0FFFFFH. That means up to 64K. The segment registers are given here. The offset is given. So the physical address what we will get, that will be segment register plus offset, and it will gives you the physical register. That type of little bit problem you may face in your several competitive exam. So please remember, please follow the screen. If you have the segment register or the offset value, then the physical address you can able to find by adding these two. Okay, here data is usually phased with the respect to the DS register, and the effective register EA is offset. EA depends on addressing mode. So EA means addressing mode. So here the segments you can able to get from here. Okay, so this is the data segment. I repeat once again, this is the data segment. Please follow the picture, and what way you can get the segment register, offset register values and physical address, this you have to get from here. So this is the part. Okay, now after this discussion we have to discuss one thing more, that is the addressing mode. Addressing mode, where from the assembler's activity is coming. Our next lecture we will discuss about the assembly level language. Right now just get this idea. Here what we are telling, in case of the addressing mode, what we are getting here, SAM. SAM means, that is defined as the word 16-bit variable with the memory location and contain 25H. This SAM DW25H, if it is given, this is the assembler directives. Then FRED equal EQE 20H. This gives you Fred is not memory location but a constant. That means I am giving here equal, that means it is right now become constant. Here you have to remember two things: direct addressing, immediate addressing. What will be their code? If I am writing MOV move AX SAM, then it will gives you direct addressing. Here the SAM AX contain the SAM is a put into AX. The CPU goes to memory to get data. Immediate addressing, move AX Fred. It is giving you that it will be data will, memory will get the data, and data is the instruction. It will immediately, it will fetch. So this is the addressing mode. In detail, I think this slides you cannot able to get properly, because you have to know the assembly level language. I will tell you, don't worry, next lecture will be on according to that. Now the addressing mode, what way it will work, that I am discussing here. It is the very introductory part of 8086. So assembly language details, assembly language program, we will tell you, don't worry about that. Next video, wait for the next video. Maybe within one day you can able to get it. There you will get the detail. Before that, already you have instruction sets in 8085, and in 8086 how they are working, their instruction sets we are discussing. So just right now, the what are the addressing mode, what are the address modes, just like previously slides. See here, register addressing, register indirect, register direct, this all, and the indexed and based with the placement, what way it will work, this all will be discussed. Right now just you see what way they are working. Okay, just follow the screen. When I am writing MOV AX BX, then AX BX, whatever the data, that will goes to AX, it will be moved to there. Now the register indirect, then move, I have to write move AX comma within bracket BX. That means BX through the DS coming to AS. Okay, just follow the screen along with my lecture also. Please follow the screen. It can use BX and or SP for the base addressing. Now if I have DI and SI, then the index addressing also you can able to get. So these are the part where we are writing just move AX, SAM within bracket BX, that means register indirect with the displacement, the index with displacement, based with displacement. These all you can able to get from this lecture. So up to this level, I think it is right now clear to you what's the internal architecture, what way it will be segmented, and how the address modes work. Obviously there with their features, because without features any microprocessor cannot stand and cannot start. So up to this level I think it is clear to you. Now one thing I have to tell you regarding this matter, 8086 is 16-bit register and it has 20 address buses. So if I have 20 address bus and 16 data bus is combined with address bus, so you can able to get that all the instruction here it will work very larger way, more larger than your 8085. So there the address modes working methodology will also little bit change, and that's the thing what I discussed here. So follow the screen please. Here the course is written, instructions is written, please follow. It will be better to get, because 8085, 8086 these all are microprocessor. So here all thing will be done, all the program means nothing but the fetch, decode and execute of our instructions. One thing you have to remember, anything microprocessor means they have nothing to do. They will just execute the program. Do the program, execute the program. In our computer science everything is just like that. Therefrom we have to generate the algorithms, we have to generate the sequences, any other thing, but it is the main motto. So this is clear I think right now. So next what we have to discuss here, that I already told you what way the address mode work. Now what is this address mode's detail that I have to tell you before ending this video, this lecture, this tutorial. So just the thing is that, just see, the addressing modes means what? Instructions are always fetched from the code segment. The IP pointers points the next instruction to be executed, that is CSIP. Now data usually comes from data segment. However, data can be fetched from any segment by use of segment override prefix. See here, move AX EX, that is the data in EX and BX. Move AX BP, move AX CS SI, and move AX BX. What will the data will change, that I am showing it here. Now one thing you have to remember, when I am giving the move, that means moving the test segment. When I am giving SAM is decode, and when I am giving just DS, that is the assembler generates the segment to override the segments. So that way one instruction may be used in several ways, several purposes. Here DS is assumed to be as an example. So here instead of DS you can use any other things also. So what way any one statement can be, one instruction can be modified, that I am showing in this video. After this is this video. Here you can get the little bit idea about this addressing modes related, branch related information, where the near and far instructions and into our intra segments is coming, you can able to get. So read it. Our next video we will explain more. Till that, one thing I have to tell you, after this video, you can, if you think it is better for you, you can able to get. So don't forget to like and share. Obviously share through your Facebook, Twitter or your WhatsApp. And don't forget to subscribe our channel and press the bell icon to get it.